Now we are going to discuss about the one important topic in optical isomerism, that is configuration. So what is this configuration? The arrangement of atoms that determines the particular stereoisomer is called as configuration. We want to identify what kind of stereoisomer that will be determined by means of this configuration. There are two types of configuration. One is relative configuration, another one is absolute configuration. Let us see what is what. So first one, relative configuration. This relative configuration, which is otherwise known as D and L configuration. In this type, the compound, we are relating the isomer with the standard glyceraldehyde. So if that particular compound is related to D-glyceraldehyde, then it belongs to D series. Similarly, if it is related to L-glyceraldehyde, then it belongs to L series. That's why it is called as D and L configuration. This relative configuration, which is otherwise known as D and L configuration. Here we are taking the standard glyceraldehyde. This is the structure of standard glyceraldehyde. CHO, HCOH, CH2OH. This one is L-glyceraldehyde. Here you will find the structure CHO, OH, CH, CH2OH. So here we have taken one more example, that is the alanine structure. That is CH3, CHNH2, COOH. This is the structure of alanine. Here we are relating this alanine with the standard glyceraldehyde. So it is, here you will find this CHNH2. It is related to this D-glyceraldehyde. Hence it is belonging to D series. Similarly, L-alanine, you will find the structure CH3, CHNH2, COOH. So this one is relating with the L-glyceraldehyde. Hence it is belonging to L series. So one disadvantage of this method, here we are seeing the structures very small in structures. So we can easily identify and it belongs to this series, likewise we can tell. But if it is a complex structure, it is difficult to give the configuration. So in order to overcome this disadvantage, one more configuration, that is known as absolute configuration. This absolute configuration, which is otherwise called as R and S configuration. In this method, we are taking the compound, we have to visualize the compound. How we are visualizing? The atom or group which is having the least atomic number should be kept away from us. Okay, then we have to visualize in such a way the atom which is having the highest atomic number will get the first preference. This is followed by the next highest atomic number and so on, and afterwards the next atomic number. See, we are taking the compound and the atom which is having the least atomic number should be kept away from us, and the atom which is having the highest atomic number will get the first preference. This is followed by next atomic number, likewise it will go on. So now you are doing the visualization. If your visualization is from left to right, then it is or in clockwise, it is called as R configuration. If your visualization is from right to left or anti-clockwise, it is called as S configuration. Here R stands for rectus and S stands for sinister. Here we are taking one example, that is bromo, chloro, iodo, methane. This is the structure of bromo, chloro, iodo, methane. So we are taking the atom which is having the least atomic number, that is hydrogen, that will be kept away from us. Here iodine, which is having the highest atomic number among these halogens. So first you have to visualize first iodine, then followed by bromine, then chlorine. So here your visualization is from right to left. Sorry. Then this one is known as S configuration. if your visualization that is just opposite, so here iodine, bromine, chlorine. So this is from left to right, that is clockwise direction, hence it is called as R configuration. This is about the absolute configuration. So it is otherwise known as R and S configuration. I hope you could understand this absolute configuration as well as relative configuration. Thank you, Anand.